So we're looking at radical equations, but before we do that, let's just recap a little bit as to what we were talking about in our previous classes. We had this part where we were completing the square. So remember, to complete the square, we took half the b term and then squared it to get our magic number. So our magic number was 25. So we do plus 25 minus 25. Then that allowed us to factor. And then once it's in vertex form, the vertex is really easy to find. And we can do all kinds of stuff. Talk about domain and range and which way it opens, if it has mins, maxes, increasing, decreasing. So all kinds of information once we are able to find the vertex. Okay. Before we did the completing the square, we were doing something similar, vertex form here, but we were writing the equation, okay, where we took the vertex and plugged that into vertex form, and then we had to solve for a in that respect. Okay, so that was prior to that, and then that's, you know, kind of where we were doing all of that quadratic stuff, where we talked about x-intercepts, y-intercepts, axis of symmetry, domain, range, all of those things when it comes to quadratics. So as I said, today's is going to be a little bit different. So I'm scrolling down in our notes and I'm going to get down to I'm not doing the 2.5 solving the higher degree polynomials. We'll do that at a different time. But here where we are solving equations, whoops, sorry, not the rational exponents, solving equations involving radicals. All right. I'm going to start off actually by replacing question B with something a little more manageable to start with. Let's say we had the radical equation of the square root of 2x minus 7 is equal to 3. It's a radical equation because it has a radical in it and because it's an equation. So what we want to do first is we want to get rid of the square root. So we do the inverse operation. The inverse of taking the square root is squaring. Well, what we do to one side, we have to, of course, do to the other side. So I'm going to square both sides. So the left side gives us 2x minus 7 equals 9. Add 7 to both sides, so I have 2x equals 16, and x comes out to be 8. And we could always plug that back in to check. You know, so I'm plugging an 8 in for x there. So if I did the square root of 2 times 8 is 16 minus 7, that's the square root of 9, which does equal 3. So it works. All right, and that's a fairly straightforward radical equation. All right, let's do part A, which gets a little bit harder. Similar problem in part A. We have a square root. We want to get rid of the square root, so we're going to do the same thing and square both sides. So squared and squared. Now, on the left side, the square root and the squared, those operations cancel out, and I get 2x plus 7. On the right side, I have to FOIL this. So don't forget that that is a FOIL part. We're not just going to write that as x squared plus 4, but we have to FOIL it into x squared plus 4x plus 4. That's x plus 2 times x plus 2. So now it's a quadratic. We get everything on one side. And so here's a definite tie-in to what we were doing prior to this. So I'll move everything to the right. I have x squared plus 2x, okay, because I subtracted 2x, and minus 3 because I subtracted 7 from both sides. And let's see if this thing factors. It looks as though it does, into x plus 3 times x minus 1. And so we get two answers of negative 3 and positive 1. All right, not so bad. But don't miss this next part because we're actually not done with this problem. When you have square roots, they sometimes give extraneous solutions. Let me show you what I mean by that. I'm going to take negative 3 and plug it in here. And so I get the square root of 2 times negative 3 is negative 6, plus 1 or plus 7 is 1. So that's on the left side. And if I take negative 3 and plug it into the right side, negative 3 plus 2 is negative 1. Now, when we were to take the square root of 1, when we were solving equations, we had the plus or minus situation where we would do plus 1 or minus 1 when we're taking the square root. When we are doing these radical equations, we are only talking about the principal root, meaning the positive one. So that means that this is not true, and therefore negative 3 is an extraneous solution we have to throw out. Okay, this would have to come out to be positive 1 because we want the principal root, the positive root. All right, I better check out 1. I'm going to plug 1 in for the x's. So I get 2 times 1 plus 7 is the square root of 9 on the left. And 1 plus 2 is 3. And the square root of 9, the principal root is 3. So that 1 is an acceptable solution. Okay, so the idea is, of course, be careful with those extraneous solutions. Always check them. All right. Any questions before I move on to the next one? Because they're going to get increasingly harder. All right. Well, let's roll along to this problem. One thing I noticed right off the bat is I have 2 radicals. I know how to get rid of 1 radical, like these. That's to square both sides. To get rid of 2 radicals, I'm going to have to square both sides twice. So let me tell you what not to do. Do not just square this, and square this. Okay, that does not work that way. We can't just do 2x plus 6 minus x plus 4 is equal to 1. Okay, that is a big no-no. We have to first get one of the radicals by itself. Doesn't matter which one. So I'm going to leave this on the left side and move this guy over to the right side. And it doesn't matter which one you get by itself. So I'm going to write the square root of 2x plus 6 is equal to 1 plus the square root of x plus 4. But you want to isolate that radical and then square both sides. And now that's going to get rid of a square root on the left. It's not going to get rid of both of them, though. So on the left side, we get 2x plus 6 because we have the square root squared. But on the right side, don't forget, that is a FOIL. We have to do 1 plus the square root of x plus 4 times 1 plus the square root of x plus 4. So that FOILs into 1 plus 2 square roots of x plus 4 plus x plus 4. So I FOILed out the right side. All right, I'm not done yet. I'm just pausing to let you catch up with the work because I still have a ways to go. I still have a square root. So what I need to do is get that square root by itself and then do the process again, square both sides. So to get that square root by itself, I'm going to move everything away from this. So I'll move the x over. So I subtract x from both sides. I get x. And I'm moving, 1 and 4 over. So that's going to be plus 1. I'm subtracting 1 and then subtracting 4. So that equals 2 times the square root of x plus 4. And now I could do one of two things now. I could divide by 2. It's going to give me a fraction, so I'm not going to do that, but you could use that method. At this point, I'm going to square both sides. Now you can see where this gets a little trickier again, because we have to FOIL on the left. That's going to be x squared plus 2x plus 1. And on the right side, I have to square this and square this. So on the right side, 2 squared is 4. And then the square root cancels. So I get 4 times x plus 4. So we're still getting there, but at least I got rid of all the radicals, and now it's a quadratic. I got to distribute the right-hand side, and then I'm going to get everything on one side. So I have x squared plus 2x plus 1 is equal to 4x plus 16. And I have x squared minus 2x minus 15 is equal to 0. Looks like that guy's going to factor into x minus 5 times x plus 3. And so our answers are 5 and negative 3. Now, I really hope you're screaming at your computer screens right now saying, wait, we have to check our answers for extraneous solutions, because we always have to do that with radical equations. So let me take the 5 and plug the 5 in first. So I'm plugging 5 in for x, and I'll write it up here. That's going to be the square root of 2 times 5 plus 6 is the square root of 16 minus the square root of 9, because 5 plus 4. And so that's 4 minus 3 does equal 1. So it looks like 5 checks out. That's good. And now plug negative 3 in for x. So I have the square root of, that's negative 6 plus 6, which is 0, minus the square root of 1 is equal to 1. And that does not check out, because that says that negative 1 is equal to 1. That does not check out. Therefore, negative 3 is extraneous, and we would have to throw that out. All right, you got any questions for me before I have you guys try some on your own here? So I did have the question, does the positive number always work and the negative number always cancel out? No, that's a very good observation. It appears that from these examples, but no, that is not necessarily the case. It's only what happens when you plug them in. It's only what happens underneath the square root that you're concerned about. You can never have a negative under the square root, of course, because then that would be a complex number. Okay, but the negative does not always cancel. It's a little bit of a coincidence from here. So really good question. Any other questions before we move on? All right, well, I'm going to have you guys do 3 or 4 problems on a class kick, and then we will work on those together. So to go over the class kick together here, we have a radical equation. We want to get the radical part by itself. So the first thing we should do is move that 19 over to the other side. Some of you guys did not do that. You just tried to square both sides first. Remember, you got to get the radical by itself first. So I'll subtract the 19 over. We have the square root of 3x plus 19 is equal to 1. Now we want to square both sides. When we do that, we get 3x plus 19 on the left equals 1 on the right. And then we just solve. So 3x is negative 18, or x comes out to be negative 6. Now we should, of course, check that answer. So if I take negative 6 and plug it in for x, I get the square root of 3 times negative 6 would be negative 18, plus 19 would be the square root of 1, plus 19. That does equal 20. It checks out. So negative 6 is good for the first one. All right, for the second one, the radical is by itself, so we are ready to square both sides right now. So when we do that on the left, we get x over 5 plus 1 is equal to 16. Now, I want to subtract the 1 over. So we have x over 5 is equal to 15. Multiply both sides by 5, and x comes out to be 75. All right, again, we should double check. So we have the square root of 75 divided by 5 is 15 plus 1. That's the square root of 16, which does equal 4. It checks out, and so 75 is good. All right, any questions on the first page? Okay, then we'll keep rolling here. Second slide, we're going to square both sides. This is a FOIL on the right side. So the left side, I have 15 minus 3x. And on the right side, we get x squared plus 2x plus 1. Now I want to get everything onto one side. So I'll move everything to the right. I have 0 is equal to x squared plus 5x minus 14. And that looks like it's going to factor into x plus 7 times x minus 2, giving us answers of negative 7 and positive 2. Now, checking our work, I plug negative 7 in for the x's. I have the square root of, let's see, negative 3 times negative 7 would be 21, plus 15 is the square root of 36. And that's equal to, I'm plugging a negative 7 into here, negative 7 plus 1. That doesn't work, right? Because it's not the principal root. Okay, square root of 36 is positive 6, not negative 6. So that means that negative 7 is extraneous. Now we also have to check the next one because there are cases where we get no solutions. So let's take 2 and plug it in to the x's. So we have the square root of, that's going to be 15 minus 6, or the square root of 9, is equal to 2 plus 1. That does check out, and so 2 is our solution. All right, last one here. This is where we're going to have to square both sides twice. Some of you moved this 2 over and then squared both sides, which you can do and should get the same correct answers. But this actually is ready to have both sides squared right now, because it doesn't matter which radical you get isolated first. So some of you did it this way also. So I'll do it this way. On the left side, we're going to have to FOIL. The square root of x minus 2 times the square root of x minus 2 is going to give us x minus 4 square root of x plus 4. Okay, I got that from FOILing out that left side. And on the right side, we have x minus 5. So we'll get everything on one side. So I'll move everything to the away from this radical. So I have negative 4 square root of x equals, the x's cancel, of course. So that equals negative 9. And now I'm going to square both sides again. Now, when you square the left side, don't forget it's 16 times x. You have to square this and square this. And that equals 81. And I don't know why I'm writing in green here. Sorry, guys. So I had 16x is equal to 81. So that means that x is 81 over 16. And that looks kind of ugly. So let me show you guys a nice little trick here that can help you check your work. I mean, we have technology at our fingertips. You know our handy dandy graphing calculator? That if I were to go to new and calculator, it will actually help me check that or solve this problem for me. Under the toolbar in algebra, there's a lot of awesome stuff you can do. So I'm going to hit algebra and I'm going to hit solve. And I'm just going to type in that equation that we just did. So the square root of x minus 2 is equal to the square root of x minus 5. Now I have to tell the calculator what to solve it for. So I hit comma x. That tells the calculator solve it for x. And look at that. It's 81 over 16. So I feel good about the answer there. All right. Any questions before we go?